So the next concept is wave equation in terms of magnetic field. So in terms of magnetic field, we are now going to derive the equation. Okay, so for this same, consider the same medium which is both lossy and free charge. So both lossy and free charge, sigma is not equal to 0 and rho v is equal to 0, and from time varying Maxwell's equation, from the non-existence of monopole law. So non-existence of monopole law, so we have del dot b bar is equal to 0, but what is b bar? B bar is equal to mu h bar. So del dot mu h bar is equal to 0. Since mu is a constant, we get del dot h bar is equal to 0. Okay, so now consider the modified Ampere's law. So modified Ampere's law of time varying fields. So of time varying fields, Maxwell's equation of time varying fields. So we have del cross h bar is equal to j bar plus dou d bar by dou t. So but we know that j bar is equal to sigma e bar, okay, and d bar is equal to epsilon e bar. D bar is equal to epsilon e bar. So and taking curl on both sides, what we'll get is del cross h is equal to del cross, so in the place of j bar we have sigma e bar plus dou d bar by dou t can be written as epsilon into dou e bar by dou t. Okay, so from vector triple product we have del cross h bar is equal to del dot h bar minus del square h bar. So but we have del cross h is equal to 0, so del cross h can be replaced with minus del square h. So this becomes minus del square h bar is equal to sigma into del cross e bar plus epsilon into dou by dou t of del cross e. So from Faraday's law we have del cross e bar is equal to minus dou b bar by dou t. So substituting this del cross e here and here, so we have minus del square h bar is equal to sigma into del cross e is equal to minus dou b bar by dou t plus epsilon into dou by dou t of del cross e can be written as minus dou b bar by dou t. So but we know that b bar is equal to so substituting this del cross e bar is equal to dou b bar by dou t here, so you'll get like this, but we know that b bar is equal to mu into h bar. So substituting this equation, what we have is del cross h bar is equal to sigma into minus dou by dou t of mu h, okay, plus epsilon into dou by dou t of minus dou, in the place of b bar we can write it as mu h bar by dou t. Okay, so mu is a constant, you can write outside, minus del square h bar is equal to minus, I'm taking minus common in both the terms, so minus I'm taking total common, so sigma mu into sigma dou h bar by dou t plus, so this becomes mu into epsilon, so mu into epsilon dou by dou t of dou h bar by dou t will become dou square h bar by dou t square. So in these two cases minus and minus gets cancelled, so the final wave equation in terms of magnetic field is given by del square h bar is equal to mu into sigma dou h bar by dou t plus mu epsilon into dou square h bar by dou t square. Okay, so this is the final wave equation in terms of magnetic field. So if you observe here, entire term consists of only magnetic field components. So this is the wave equation in terms of magnetic field, and previously we have discussed the wave equation in terms of electric field. So these two equations are very important and should be remembered for the exam. Okay.